So for this project, you were given the situation as stated. Just before 6 p.m., students enter the classroom to find Mr. Fees dead of an apparent homicide. Everyone said they saw it coming. At 6, the temperature of the body was 80 degrees, while at 7, it was 75 degrees. It took a while for campus police to get through the party. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? And you are instructed to determine and discuss the value of K, determine and discuss the approximate time lapse to the nearest tenth from time of death to time of discovery, and determine and discuss the approximate time of death. And this is the equation you are instructed to use, with these being the variables. So based on that, you will then set it up as 75, which is the temperature of the body at the time of discovery, equals 70, which is the constant temperature of the room, 80 minus 70, 80 being the temperature of the body at 6, 70 again being the constant temperature of the room. E to the negative K, 1, because it took 1 hour for the police to arrive. At this point, you then subtract 70 from both sides, leaving you with 5 equals 80 minus 70 E negative K 1. Then you subtract 80 and 70, so 5 equals 10 E negative K to the 1. And then divide both sides by 10, leaving you with 1/2 equals E negative K 1. You then have to find the ln in order to cancel out E. So you are then going to find the ln. So ln of 1/2 equals negative K 1. Then you need to get rid of this 1, so you divide both sides by 1. And you are then left with ln 1/2 over 1 equals negative K, and you can't have a negative, so you divide both sides by negative 1, and then you are left with K equals ln 1/2 over negative 1. And when you put that into a calculator, you are given K equals negative 0.6931. So that is your K value. From this point, you then set up the same equation, but instead of this 75, you will use 85 or 98.5, because that is the temperature of a living body. So E do 98.5 equals 70, 80 minus 70 E, and then you will plug in your K value for K, and you will not plug in 1 because you're trying to find T now. And don't forget your parentheses. So you'll have a T instead, because you're now trying to find the time elapse. So once again, subtract 70 from both sides. You're given 28.5 equals 80 minus 70 E negative 6931 T. So you once again subtract that, so 28.5 equals 10 E so again, divide both sides by 10. Sorry, doing this while holding it is not easy. Then you're given 2.85 equals E So once again, you have to find the ln to cancel out this e. So you're given ln 2.85 equals negative 0.96931 t. And then divide both sides by negative 0.6931. And you are then given ln 2.85 divided by 0.6931 equals t. And then when you put that into a calculator, you're given t equals 1.5. So your time elapsed is 1.5, which then also equals 1 hour and 30 minutes. So then the time of discovery was 6 p.m. So subtracting an hour and 30 minutes from that, you are left with an approximate time of death of 4:30 p.m.